we said last time, Snap Hex Mesh is a good tool to construct the complex geometry within OpenFOAM. But sometimes the mesh may have some problems, and for even more complex model or some CAD model, it might be easier use a third-party software package to build the mesh, and then can be used by the OpenFOAM. There are many third-party software, meshing software only that can be used, can be closed sourced, commercial, or open source. Now I will tell you or show you how to use open source software package to build the mesh. So the software package I used is called SALOME. So it is very wide range use for different applications, not only for the CFD meshing, but also for the finite element meshing. So we will only use its geometry and meshing functions, and that will be our main applications for the OpenFOAM. And there are 10 steps I summarize here. So the first step I mentioned is to export the CAD models of each region to the step files. So if you still remember, in the previous Snap Hex Mesh, we have two models. One is water, one is air, that can be extracted from the background mesh. So that mesh has the STL file, but now I want the CAD model into STEP file, which is more like a solid object files rather than the surface object files. So I have copied these two files here. So I built a new folder called just and the SALOME behind it, which means it is a new folder, and I have add these two step files. So if you want to check if it's in parallel, you can do this here. And if I assemble, if I only display one, so this is for the air, and if add the other or hide the other, it will be the water. So they form the heat exchanger we are interested. I want you to pay attention about the axis. So the axis, you can say for x is from 0 to minus 200, which means I currently have the geometry or units or dimensional units in millimeters. So that is something you need to interested or you need to focus on, because in the following or for the OpenFOAM, so the standard unit to be used is the meter. So SALOME is actually a very good integrated user interface. So this is SALOME interface here. So it has different operations depending on what you are doing. So it's quite similar to some commercial software packages. So I'll start from the geometry. So in the geometry, I have several operations. So several operations from number 2 to number 5. So I will show it here separately. So after I have the CAD model ready, in the geometry, we firstly to import the STP files. So I will use the import STP file. So it also allows others. So even STP files here, so you can use, but I'll use STP files at this moment. So I will go to this folder as my working directory, and I will import both air and water. So it says take into account the units embedded file. So if ignoring the unit, we call model scaling. So if I use, I can just do this as no. So if as no, the model I used can be in millimeters or meters. It doesn't matter. We can scale it later. So I will use no to all, so it will give the two bodies here, which is exactly the files, the model files, and will be used for the further operation. So next step, select all the bodies and use partition to glue the regions and split the shear faces. So it's quite, because I built two bodies separately, I need to guarantee the interfaces between the water and air is very tightly merged. So I will use the operations and partition here. So these two objects is I use. So I just use if I select these two bodies here, I just apply and close. So apply and close. So it has the partitioned objects which has been created by this operation. So you can see in the third party or the professional meshing software, everything is by the menu, and you just select and click. So that is for the benefit of using. But if you click here, you still have the two bodies here. What I'm going to do is create the new entity groups. The new entity groups means I will use this as the cell region. So right, cell region for the water or for the air. So now I currently use, and if I use this and so this will be the region of air, right? So sorry, I'll just try that. I'll show that again by using group, by using create group, and I will use this, and I will choose this, and that will be the air. Remember, we must add this region here, so that's air. All right, and I can apply, and then I will use the water, and I will use this, and that will give me the water. Apply and close. So that is two separate groups, volume groups of air and water. So if you can click this or hide this, you will see the difference of that. So I can save it at this stage. I can use the heat exchanger, just showing this, and then that is actually the basic deformation of the volume for the partition object. And also I want to create the face group for all the boundaries at the interfaces between the regions. What do I mean is, if you still remember, in the OpenFOAM we create the patches layer for all this, but now I need to try to create the air and also the water, which means the different patches for the inlet, outlet, and also the external wall. That we need to do, and then in the further operation it keeps easier that you can define the geometric boundaries. So I will use this. I will starting from the air anyway. So from air, and I will create a group of face, right? So group face. So group face, I rotate this to the inlet and outlet. So the top is the inlet, if you still remember. So I will just use the same name for the air inlet, and I will create this face, right? So remember, I currently have the face number of 104. So if you have a paper, you can write it down, because the 104 is something you need to remember to avoid in the further operations. So that is inlet 104, and I will apply it, and air outlet. So that will be the bottom one. So I will just rotate a bit, and I will choose this. That's 84, right? So 84 is the faces for the outlet. So I'll apply. So what extra we have? The extra we have is about the interfaces between the air and water, right? So that is inside, if you still remember, that is inside the air and water region, right? So that is a bit more complicated because some of the faces actually hide, right? It's hide into it. So what I'm going to do now is I will try to do the external walls first. So if you still remember the name of the external walls, I use the air to domain 0. So I will explicitly define a name which is exact the same name with the previous. So this will be the external walls, right? So the external walls, and I use the shift to click another. So this will be the internal walls, and this will be the external walls, and just rotate a bit, and this will be external walls. Just this will be the external walls, and the other side. So this will be the external walls as well. So that is external walls definition. So 1, 2, one side, the other side, one side, the other side, and maybe I have another external wall should be defined because there are some corners like here and here, right, and here. So I should have select all the external wall at the stage, then I just add. I will apply and close, then I will have the external walls defined, right? So this is external walls. So if you want to show, you can see if it's correct. So now it's air to domain 0. It's mostly the walls only without inlet and airlet, and also internally it has no any water to air interface. So that we are going to do next. So how to do that? I will just create a new entity, a new group, which is the faces still, but now I use all faces, all air faces. All air faces means I will choose all the face because I have function for here called select all. That means every interfaces, including the previous ones, will be created. So I will use this apply and close, and all the air interface is actually include all the faces of the previous one. And now I just need to have operation here called cut groups. As we said, we did this because it's very difficult to choose the interfaces internally, but I can use all the interfaces and then subtract the face that has been selected for the air, which is the external one, right? So the main group, so firstly I name the name is air to water, and the main group is all air interfaces, and the tool group I will choose the air inlet, air outlet, and air to domain 0. So 3 objects, and then I will say apply and close, and then the air to water interface, if you see here, it will be defined right by using this Boolean operation. So I'll save this after finishing the definition air, and I can hide the air region and the water region displayed. So the water it might be easier because all the faces are externally displayed. So I will follow the same groups by create an entity group and the face. So I will create the air water inlet. So if want to check the if you want to check the relative positions, you will see here. So that's actually give me some clues. So I need to put this direction, right? So this is the inlet, this is the outlet. Now I hide the air. So that is water, this is the inlet as we just displayed, and this is outlet. Now I will create the group called water inlet. So very easy to choose this and add it and apply. And the water outlet, and also to this patch or this face and apply. So I haven't added, and then that will give me the warning. Now I add this, and now I will choose the external walls for the water region, so that I also use the water to domain 0, right? So these are so they have been defined here. So this is 1, 2. I will choose this as well. So 1, 2, 1, 2, 3, 4. So that's 4 for the inlet surrounded, and then 5, 6, and 7, and 8. So the previous one might disappear when I rotate, so I need to do that again. Does that give me everything? And so 1, 2, 3, 4, 5, 6, 7, 8. Right, that's 8 faces for the external walls, and we'll apply. And then I will do the same. This time I will do this all water faces, and then I will just subtract all the air. So the water inlet, water outlet, water to domain 0, and we'll have the water to air, right? So I select all, I apply and close. So this is all. I just have double check if it is correct. So I'll put the air on and display it as the inlet and outlet on the top and below, and just have a quick check of all the interfaces. So this is the inlet, this is outlet, this is water to domain 0, and this is all the faces. Now I still need to use the group and called cut groups. So I will name it as water to air, and all the faces will be the main group. The two groups it will be the ones I have defined, the 3 objects. So I will apply and close, and then I will define the water to air group. So now all the faces has been defined, and that is what we did for the geometry processing. So we actually did 3 main operations: is gluing the regions to make them share the same face, and then create volume groups for the air and water, and the face group for all the boundaries, right? So I also name the boundaries as the same name with my previous one, just help me easy to do it in the further. So that is for the geometry operation using this software. I have done this. and now I'm ready to do the next operation.